In this video, we're going to talk about functions. Whenever you think about a function, you should think about a program or a piece of a program that breaks a problem into smaller pieces that we can solve one at a time. Functions also allows us to easily be able to reuse code. Up to this time, we haven't had an easy way of doing that except doing it like a copy and a paste. But that really isn't very efficient, especially if you find a bug. You have to go through each place where you would have, where you copied and pasted that code and make adjustments. Functions allows us to be able to write more compact code and make it easier to read and easier to understand. We've already been exposed to some functions. The functions that we have talked about so far have been built in, which means that Python provides them for us. And we've talked about how to execute those functions. But what we're talking about here are user-defined functions. In other words, functions that you and I define ourselves. So to define a function, we start off with the keyword def for definition, then a name for the function, and then any arguments that it may have. You may think, well, what's an argument? Well, we'll talk about that in a minute. And then the code that makes up that function, and we call that the function body. So the best way to really learn about this is to look at an example. One thing that's very useful is there's times that we want to ask the user for a positive integer. So we can write our own function that'll do that, and then we can call it as many times as we'd like. So here's an example that does that. I'm sorry that some of the comments are spilling over, like this one, and then this print statement here is spilling over a little bit. So it's not as clean as it could be, just with the way that the code is displayed on the screen. But it's not really as complex as it looks. So let's start here. I actually, at the top of my function, I put a comment that explains what the function does. That's a good programming practice to follow. It just makes things a lot easier. I give the name of the function, get positive integer. I've got the name of the function then that is called get positive integer. This roughly follows the same syntax or the same rules that we use for naming variables. Excuse me. You don't want to start it with numbers. You usually want to start with a letter, and then underscores to represent breaks if you want. That's one way of writing code. You could also uppercase the G, and then instead of having an underscore here, have a uppercase P. And so that way the capital letters would be kind of the word break to get an idea of where the next word starts. And then our variable, our argument that we're going to have is message, which that's going to be the message that we display to the user. So we can get a positive value. So the first line of code here is an input statement. We're asking the user for some positive value. And then the rest of the code checks to see if that input is positive integer or not. So we have a try statement. And we try to convert the string value that's inputted from the user to an integer value. And so if this doesn't throw an error, just check to see if the value is greater than or equal to 0, because remember, we can have negative integer values. And so if that's the case, then we use a return to return that value, a return statement to return that value to our main program. If our if statement, if the value here is less than 0, we print out an error message stating that the value that the person inserted is not a positive value, and then we ask them again to input a number, a positive number. In the try, if something happens to where this is where we can't convert the value to an integer, the except gets executed or thrown, and then we print out a message stating that the value that the person inputted is not an integer, and then we ask again for some input. So one thing that you can do is copy and paste this into Thony or some other editor and execute it, and maybe try a few different values, see what you get. See if you get, see if there's any bugs. There possibly could be a bug. I don't think there is, but there, you never know. And let's do that because we need to talk about how to execute the code ourselves. So what I'm going to do is in the shell here, I'm going to paste this. Let's see if it'll paste. Maybe not. Let me try again. Let's try copy, try paste. And actually, I need to go back up and fix a little bit of this. Notice that none of this is indented properly, which really sucks, but that's just the way it is. This would be a good exercise in inputting the values. And actually, what I'm going to do is do it up here, so that way if there's a mistake, I can fix it. That's what I suggest that you do, because there could be a problem, and if I don't fix it right away, then I just lose all of my changes. So if I fix it up here in the editor portion, if there's a problem, then I can just fix it again in the editor portion, and then fix the part that's wrong, and then I don't have to keep doing the same work over and over again. And that's part of the comment. This is part of the print statement. And the accept, let's make sure that lines up properly. Put that over there. So when you're done, your function should look roughly like that, I believe. And we'll double check it in just a minute. And let's put that in result, and we'll print out the result. And I'll probably have to save this to get it to execute. So save as. And for right now, I'll just call it temp.py. So let me execute this and let me see what happens. Okay, oops. Yep, that needs to be like that. Enter an integer, let's say 5, enters a 5. Let's try, and I don't really care how it does it that way, so what I'm going to do is put a colon here and a space. So now see, now it doesn't run up right against my message there. So let me put in a negative number. Let's say negative 15. That's not a positive integer. And it outputs error. Negative 15 is not a positive integer. Please enter an integer. Let me try pi, see what it does. Error, entered value 3.4 is not an integer. Please enter an integer. I can try a negative float value. Let's try negative 2.78. That's not an integer. And so this keeps going through this loop until we enter in a positive value. So I'm going to enter in a positive value, let's say 5, and it's done. So there you go. This is the way that the function should look like, and this is the way to execute it. One of the things that's really powerful for this is, let's say, for example, we want to calculate something like, if you got a triangle, or let's do this. Let's say the area of a rectangle, because that's pretty easy. So let's say we've got two sides to a rectangle. And so we can calculate the area by just multiplying those two together. So we could do this. Area of rectangle is, let's see what happens. Okay, side of rectangle, please enter side 1 of rectangle. Let's say that our rectangle, it has a length of 10 and it has a width of 3. Now we all know that that's going to end up being 30 because it's 10 times 3. We do the math, there we go. We say the area of the rectangle is 30, and that's pretty easy. If we try to execute this again, and we know that our length has to be a positive value, it can't be negative. Technically, we could have a rectangle of 0 length. If that's the case, then technically isn't a rectangle. But for this situation, we're going to assume that 0 is a positive value. But if somebody would enter in like -4, well, -4 can't be a side of a rectangle. But if somebody enters that, our function, our code here will throw out an error message, and it will come back and ask, hey, enter in a side, the length of the side for the rectangle. So if somebody goes, oops, I entered in -4, I meant +4. The second side, oops, I entered in -5, but it should be 5, and it outputs 20. So notice here, this is 17 lines long, but notice that here we call our function 2 different times. The first time here to enter in a value for A, and then another time here to enter in a value for B. Notice how compact this is. Once you understand what this function here does, get positive integer, you can kind of abstract what that does. We know that it's going to return a positive integer value. And so then we don't have to think about all of the logic that goes in behind that whenever we call this function, because we know that whenever this executes it, whenever it returns a value, it's going to be a positive value. And the same thing here. So functions are a very powerful thing. They allow us to be able to write more compact code that's easier to debug, easier to fix. It also allows us to be able to break a problem into individual pieces. Notice that this code here, the problem we're trying to solve here is we want the user to enter in a positive value. We won't accept anything but a positive integer value. And so since this function does that, when we get down here, we don't have to worry about that problem anymore. We can assume that that's solved. And the problem now that we're trying to solve for the last 3 lines of code is, okay, we need to get a value. We know that the values that are going to be returned will be positive, and then we just got to print out the message and then do the multiplication to do the calculation for the rectangle. So as you can see here, this allows us to be able to break the problem into smaller pieces, solve each one individually, put the pieces back together. So this is a very powerful tool, functions are. You know, we've already used functions in the past, like whenever we're talking about strings, we use a length function. There's all other functions to be able to see if you know, for example, length of the string, but then are certain characters in the string. If we can find certain sequence of letters in a string, that kind of stuff. So that allows us to be able to perform a job, to be able to do something and not have to worry about all the intimate details of that function. We can think of it as a more higher level abstract concept once we get done developing it. So going back here, let's look at another example. Let's say we want to write a function that that sums up a list of numbers. We'll call it summation. It's very popular in mathematics. Here we will define the function summation. We have a variable called n that it will input from the main program. We have a variable called sum that we initialize it to a value of 0. And then we go from 1 to the value of n. Notice that we got n plus 1 here. Remember that the range function goes to n minus 1. It goes to the value right before this value here. So to make sure that it includes our value of n, we got to add 1, if that makes sense. And then we sum up the values of I up to the value of n, and then we return that. So here we can do a summation, let's say of a value of 5, and we can put that in a variable called result. Result equals summation of 5. Have a print statement that says the sum of 1 to 5 is result. So that'll output the sum of 1 to 5. So what is that? 1 plus 2 plus 3 plus 4 plus 5. You've got 1 plus 2, that's 3, plus another 3 is 6, plus 4 is 10, plus 5 is 15. So this should return, if I did my math right, this should return the sum of 1 to 5 is 15 if you execute this code here. So I'll leave that as an exercise for the user to copy and paste the summation function, this here, as well as this here, to execute it to see if you get a result. Play around with different values and see what you get. Also notice that the value here of 5, I've hard-coded that value in, but that can also be a variable. It don't necessarily have to be a hard-coded value. One thing you could do is extend this by using the get positive function that we defined a few minutes ago. Put that above here and then call the get positive integer value a function, put it in a variable, and then call the summation here on that and see what you get. That would be a good, useful exercise for you to do to see if you understand having these functions and calling them all. In mathematics, another important thing is the factorial, which the factorial is a lot like the summation, but instead of summing up all the values from 1 to n, we multiply the values from 1 to n. And so we can write the factorial like this. N has to be a positive number, and we have a variable called result that we set equal to 1. And then we create a loop that goes from 2 to n, because you could put 1 there as well, but you multiply anything by 1 and it's the same value. So I just go ahead and start with 2. So you go from 2 to n and add these values together. Actually, there's a bug here in my notes. It should be n+1 for the same reason that we had for the summation up here. And that is something that I have overlooked. I'll try to fix that in my notes. So by the time you look at the notes for this video, they should be corrected. They should say 2, n+1, multiply those together each time through the loop, multiply it, and then return the result. Then once we do that, then each time we want to calculate the factorial of a number, we don't have to think about the logic to do that. We can just call it. Like for down here, we ask for a number, we ask for a positive number, we then will pass that to the factorial function, and our fact variable should now equal to the factorial of this number. And so you should be able to copy and paste this code and execute it and see that you get certain, get the correct results. Let's look at a few other functions just to help drive this point home. Let's say that you want to calculate between Fahrenheit temperature and Celsius temperature. Here's the formulas to do that. And if you're like me, I always forget how to convert between the two. And so wouldn't it be nice if we had a formula or formulas that would or functions that would automatically do this, so that way we don't have to worry about that logic all the time. Or here's two functions here that perform that for us. So here I create the some comments here to kind of explain what's going on with it, and then here's the function that actually performs the calculation for us. And the same thing here for Celsius. So here's how we execute the programs. We input a value, and then we print out these here. Print out the degree in Celsius, and then run the conversion to convert it to Fahrenheit. Same thing here for going the other way around. Now, I'd like for you to pause this video and look at this. There is a problem with the logic of my code here. And it's something that I should have seen to begin with. But at the time I was writing this code, I was focusing on solving a one problem. And now looking at this again, I've noticed that I've introduced a problem here, which whenever you copy and paste this, you execute it, it's going to complain. You're going to find out right away what the problem is. But instead of doing that, look at the code and see if you see what the problem is. Maybe spend 2 or 3 minutes looking at this page and see if you figure out what it is. Let me give you some hints. It has nothing to do with the formulas. It's an error or a bug that we've talked about before, and it's just something that I overlooked. And it has to do with mathematics, though, but it has nothing to do with these formulas. It has to do with input and mathematics. See if you can figure that out. If you look in the notes that you have, it'll probably be fixed by then, but don't look at the notes in that section. Just look at this. Look at what's on the screen and see if you can figure it out. If you can't figure it out, then look at the notes, and here in a minute I'll talk about it. Okay. All right. I assume that you've unpaused the video. The problem is remember that with input, it returns a string. And what I've done here is now C is going to equal some string, and I pass it to this function here, and that's going to cause a problem. Why? Look right here. Assumes an integer or a float that represents a Fahrenheit temperature. Well, I'm going to pass it a string, not a float. So what I need to do before I print this next statement out is I need to convert C to an integer or a float. And that's an interesting problem, which let's go ahead and solve that now. That'll make this video a little bit longer, but that's okay. It's a good learning experience. So let me go ahead and do this. Let me copy and paste this, since we're going to have to do this anyways. Let's just go ahead and copy and paste all of this into Thony, and we can look at this. We haven't done this in the last couple lectures, and so it's probably a good idea to take the time, write some code, and react to what happens in real time. So that way you can see how some code like this is written and how a programmer would deal with certain code that they receive that they've written themselves or gotten from somebody else. So let me put this in some kind of a format that easy to kind of read. Put this over here and let me expand this a little bit. So our code looks like this. Okay, let me expand this a little bit so I can get it all on one page. So let's see what happens. We should get an error that says something about not being able to multiply a string with numbers is what we should get. Not sure exactly what the error is, but it's going to be something related to that. So let's run this. Okay. And there could be other errors. Actually, I may be overlooking something. That's the reason why we've got compilers, is because we may overlook something. So it says on line 18 that we have invalid syntax. Maybe you forgot a comma. So let me try to figure that out. Let me see what's going on. So here we have a variable, a placeholder. Here we have placeholder. Oops. Nope, nope, nope. That's okay. Since we've got this here, maybe it needs a space there. Maybe that's what's causing the problem. Let me try running it again. Let me see what happens. Nope, it's still complaining. Let's see if I got the right number of parentheses. No, I don't. That's what the problem is I don't have the right number of parentheses. Notice that this one's blue. This one over here is finally blue. If I take that off like what it was before, notice this is blue and that's blue. So that's a common mistake, is that there's not enough parentheses. Same thing with this one down here. I'll have to fix that in the notes. So let me try running it again. Oh, it's actually running, but I think it's going to cause another error here in a little bit. The syntax is fine. So this is a great example of where syntax looks fine. In other words, the way we're saying it is fine, but the logic is wrong. And the reason why the logic is wrong is because since the Python compiler can compile this, because there's nothing really wrong with the basic syntax here. But the problem is we know that this value C here is going to be a string. And so whenever we try to execute this Celsius to Fahrenheit function right here, it's going to take a string and try to multiply it by this stuff, and that's going to cause an error. But to show that, let's go ahead and put in a value for Celsius. I know that 100 Celsius is 212 Fahrenheit because that's boiling water. So the only two that I know between conversion between Fahrenheit and Celsius is 0 for Celsius and 32 for Fahrenheit, which is freezing for water. And then for boiling water, it's 100 degrees Celsius and 212 degrees Fahrenheit. Those are the only two values that I know. So let's try one of these, and we get an error. And the error is unsupported operand type for string and int. So how do we fix this? Well, our temperature could be an integer or a float. And since we could have either of those, you could think, well, I could write some code to do either of these. But in most cases, we're fine with Celsius or Fahrenheit both being converted to a float. It doesn't necessarily have to be an integer. So one way we could get around this is, there's a couple different ways, but probably the easiest and that's easiest to read would be just to do something like this. So we're going to try to convert this to a float. And actually, we probably should write a function that does this. Let's say string to float. And so we're going to take some string. We want to convert it to a float. And what I'm going to do is I'm going to put it in a try statement, and I'm going to say f is equal to float of s, return f. And if there's some kind of an error, we're going to print out a statement that says error, invalid, float value. But now what do we do if we want to keep asking the user for we could write this function so that we keep asking, like we got for the positive integer. We can make sure that the person actually enters in a valid float. And the way we would do that is putting a while loop like we did for the get positive positive number. And I'll leave that as an exercise for you because it's a lot of just copying and pasting and making a few changes. What I'm going to do to just simplify this, so I'm just going to say using 0 instead. So if we get to this point, I'm just going to return a 0. It isn't really the best solution, but that's what we're going to do just for this problem that we got here, just to keep it simple. But if you don't like this solution, which you probably shouldn't, look at converting this string to float function so that it will keep asking the user for a value until they enter in a correct float value. And you can use that get positive integer function as a basis to do that on. But what I'm going to do is I'll go ahead and change this to use my string to float function like this, and to output actually this needs to be an F here, and this needs to be an F. Now if we try to execute this, enter in a temperature in Celsius, I want to say 0, and it outputs 0.0 degrees Celsius is equivalent to 32 degrees Fahrenheit. So now I'm going to say 32 to see if it'll return the 0. 32 degrees Fahrenheit is equivalent to 0 degrees Celsius. Okay, so I know that's right. And this time I'm going to try 100. 100 is equivalent to 212 degrees Fahrenheit. Enter in a temperature for Fahrenheit. I'm going to say 212. See if it gives us back 100, and it does. So this is some neat code here. Notice here how we're able to use these functions here, and then how we use the string to float function a couple of times, and it helps simplify our code quite a bit. And then if something happens, like for example, now you can take this code that we got here, and if you want to make it so that the string to float only returns whenever we got a positive, or whenever we got a float value, you could go in here and make this adjustment up here in this function and not have to change all this logic down here. So moving right along, let's go ahead and go back to continue on. This looks like it's going to be kind of a long lecture, and that's okay. One of the things we need to talk about whenever we're dealing with functions is variable scope. And you're thinking, okay, what scope? What it really means is the period of time and in what areas of code does a variable live. After you declare a variable, before we add functions, you declare a variable, it exists after you declare it, or you set it equal to a value, it never goes away. But in functions, though, we can create a variable in a function, and then it only lives in that function. It does not live anywhere else. So let's look at an example here. Let's say that we've got some calculated complex formula, and we put all that logic here in this program. So I'm going to call it complex calc. We have 3 variables, a, b, and c. And so we do some calculations here where we're actually taking a squared plus b squared minus c squared, and we return that value. The scope of this, of a, b, and c, are the length of this whole function here. Value is declared right here as equal a times a, and its scope is also the length of the function that we've got here. So let's look at a program to where we're inserting a value for a, b, and c. Where we're inserting a value for x, y, and z. We'll pass those variables for x, y, and z here, and then we output the result. If you look at this, what happens is the first variable x, whatever values it is in x, goes into a. Whatever values in y goes into the variable b, and whatever's in variable z goes into variable c. Notice that x, y, and z are not in this function. They don't exist. They don't live in this function at all. If you try to call x, y, or z, or try to reference it and somehow in this function, you're going to get an error because it just doesn't exist. The only place that x, y, and z exists is right here. It doesn't exist up here. Also, this program has a problem. If we're doing the calculations, a, b, and c, or x, y, and z need to be entered, numbers. And in this case here, that's not, remember x, y, and z are strings. So this function also has that complication of not being a number. They are strings, and that causes a problem. So we should change this to where x, y, and z are, let's say, floats before we go into the program here. And so the easiest way to do that is before each one of these, put a float function, and I will change that in the notes so that way that's fixed. But you'll see that this is my first edition of this, and there's a few errors here. But if we do that, and if we make the assumption that somebody does enter in x, y, and z, we'll make that assumption just to make the code a little easier to understand. We will see that these functions are x, y, and z cannot be executed here. And what I'm going to do is I'm actually going to write that code out here. Let's go ahead and do that. Let me just create another tab here, and let me just copy and paste this. And I'll just get rid of these little line numbers off to the side. Put the line numbers there because I thought I might be referencing certain numbers. Say, okay, line number 8, line number 9. But I don't seem to be doing that as much as I thought I would whenever I created the examples. So what I'm going to do here is I'm going to assume, just for simplicity, that the person is infallible and will enter in a number whenever we ask them to enter in x, y, and z, and there's no possibility of them entering in an invalid number for x, y, and z. If they do, they get an error. But just to make things simple, this is what we'll do. So if we try to execute this, and we'll start with something easy. Let's try 1, 2, and 3. We actually get a negative value because you think of 1 squared is 1, 2 squared is 4, 9 squared is 9, 3 squared is 9. So you have 4 minus 9. Is that right? No. 1 plus 4 is 5. So 5 minus 9 is negative 4. So we get the right answer here. But let's play around with this to talk about scope. So what I'm going to do is I am, notice what I said a minute ago. A, B, and C, their scope is just this function here. So what I'm going to show you is that we can't reference A outside of that function. So let's say I try to reference A outside that function. I try to hit execute. We get an error. Name A is not defined. The reason why is because A is only defined in this function because it is an argument here in the function. Same thing for B and C, but I'll go ahead and execute these real quick because it doesn't take any time at all. Notice that says name B is not defined. Name C isn't defined. So anywhere in here in this code from line 6 or 7 down, you try to reference A, B, and C, you're going to get an error. But you can reference A, B, and C all you want all day long in this function. But what I'm going to do is to show you that we can't reference X, Y, and Z is I'm going to put print X here. And let's see what happens. Isn't that something? Okay. The reason why this works, and you shouldn't do this, it's bad programming practice. This works because the variable X is defined whenever this calculate complex calc is executed. When it's executed down here, it comes up here and it sees the value for X, and it will then print out the value 3 that we see here. But don't do this. Don't do that. Even though Python lets you do it, and you do get a value there, don't do it. It's bad programming practice. And I myself just make the assumption that it's not possible, that it's going to output an error. And it should, but Python doesn't do that. A lot of other languages that are like Python don't do it. It allows you to be able to cheat, but don't do it. You don't want to reference a function, a variable in this function that's not defined or isn't passed as a variable. You want to only reference it in the block of code that it's been created in, or the same level of code. You don't want to do this, even though it doesn't complain. And I'll actually put X, Y, and Z here, and all 3 of them are going to work. 1, 2, 3, prints out 1, 2, 3 here. Like I said, don't do that. Just assume it doesn't work, and you'll be better off, because there's a lot of programming languages. It will give you an error for that. So it's better just to assume that all languages are going to do that, that they're all going to give you an error. You'll be better off that way. Even though it does work, better just assume that it does not work. So going back here, let's look at another example. And in this example, we're going to look at scope. We're going to look at scope as well. So we have a variable called X. We have a function called doIt that really all it does is take a variable, add 1 to it. Really, the name of that function is a very bad name. You want to name a function something that is descriptive of what it does. So what I'm going to do is change this, call it add 1 instead of doIt. We execute this, and we see we got 3, 5, and 4. So A is equal to 3, and that's the value of A here. And then we set Y equal to add 1 A. We pass the value of 3 into the function, so X here is equal to 3. Excuse me. X is equal to 3. We add 1 to it, and we return 4. We put 4 in the variable Y. And so that's why A is equal to 3 here, because the value for A does not change. It stays equal to 3. X doesn't change because it's up here. Notice that this X is here. This is a different X. The X that we see here that's passed, this value variable X is different than this variable X. They're not the same. That's why the previous example here, I assume that X, Y, and Z wouldn't work, but they do. But it's safe to assume that, you know, in a function like this, you can't reference these variables, that it has to be a new one. So this is defined X is equal to X plus 1, which is this value here, added 1. We return that value, put it into Y. So spend some time looking at this example. If you can understand why A should equal 3, why X should equal 5, and why Y should equal 4, you have a pretty good understanding of scope. Also, feel free to read my notes on that. That should explain it pretty well. Also, one thing that I specify in my notes is that it would be better, because X is a different variable than the one in the program, to name this variable in the function as something else besides X. So calling it X1 would make a lot more sense. So if we go in here, change this to 1, this to 1, this to 1, and this to 1, isn't this clear? This is what you would expect. A is still equal to 3, X is equal to 5, and Y is equal to 4. Because we don't ever change the value of X, we never change the value of A, and because the value of 3 is X1 is equal to the value of 3, we increment that variable and then return it. This makes a lot more sense, and this is cleaner code than the previous one that I showed you. So quite often that's what you'll want to do, is use different variable names in your functions than what you use in your main programs, and that will help make it easier to understand. So here's an example that does that, to where we use a variable v instead of x or x1, and this just makes it a lot simpler. Now, functions that return values, actually, we've already talked about this, and I kind of just blew over it without really going into a lot of explanation about it, is we use the keyword return whenever we want to return a value from a function. So here is a function called getData. It always returns the value of 1 and 2. And so in this example, the 1 goes into the first variable, which in this situation is the variable name first. The value of 2 goes into the second, the variable in the second location, which is second. And so, you know, if you copy and paste this code and execute it, you'll see that the first return value is 1, second return value is 2. You can change these variables if you want, the names of the variables. You could change it to F and S for first and second. And so 1 would go into F, 2 would go into S, and you can output those values that way. And so that's one thing that's neat about Python, is that you can return one value, you can return 2 values, you can return as many values as you want from a function. Some of your older programming languages would only allow you to return a single value, and so sometimes that caused complications if you had several values that you wanted to return. Also, with functions, we can have default values, in other words, as arguments into the function. So for example, here we have a function name, we have our normal variables, and then we can set another variable equal to some default value, another variable to another default value. And so let's look at an example. Let's say that we want to have a function that calculates interest, and we have a dollar amount And then we have an interest amount, which let's say that default value for the interest is equal to 2. And so here's the calculation that we would calculate to calculate interest on a loan. Actually, it's the amount plus interest is what's calculated here. So 3% interest, we were going to get a loan for, let's say, 3% interest. It would tell us how much the loan would be after a year. That's if we didn't make any payments on it. So you can say calc interest 100 would be $100 at 3% interest. If you wanted to look at it at a 2% interest, you don't necessarily have to put a comma 2 here or comma 2.0. If you leave it off, it defaults the interest variable to equal 2.0. So let's look at this. I don't know if this is absolutely correct or not. The more I look at some of this code, the more I think that maybe I've got some mistakes in here. So let's just look at it and we can fix any mistakes that we find. So here we go. Let's execute it and let's see what happens. Missing a semicolon or something. Yeah, right here. Okay, let me try to execute that again. Okay, and it works just fine. So 3% interest after a year and not paying any interest on the loan would be $103. 2% interest would be $102. So notice here on this, we could put 2.0 and we're going to get the same result. Why? Because the interest variable is going to equal 2 because we specify it here, not because we said equal to 2. But if we take this off, or let's do it like this, let's remove the 3, and we can show that these two statements are the same. The just 100 by itself versus 100 comma 2. So we should get the same value, and we do. Okay. So we can update our, how we had our get positive integer function. Let's say we just want an integer function. So it could be a negative value too. So let's say that most of the time, whenever we write our function, we are going to just say, please enter in an integer value. Instead of having to type that out all the time, we could have a message variable that we say that. We actually set that the message variable equal to the string, please enter an integer value. And then if we don't pass anything to our get integer function, it defaults message to the string. And so let's look at this. Let's see what happens whenever we do this. And I'll go ahead and put it into Thony here. And let me fix the code a little bit. And notice this code is very similar to the get positive integer. There's just a few slight differences. Mostly the only difference is we're checking to see if the integer is greater than 0. Where in this situation, since we're just asking for an integer, there are negative integer values. So we don't necessarily have to do that. So let's try to execute this. And it says, please enter in an integer value. Let's say 4. And then it's going to ask again for the variable b, get integer value. Let's say 6. And it's going to return the value of 10. So notice that here we don't specify the message, what the message variable should be, and it defaults to please enter in an integer value. Now let's try running it with another message here. So let's say for the first value that we want inserted, we want a statement that says, please enter in the length, please enter in length 1. And then for the second one here for B, we're going to just set it equal to the default. So if we go ahead and execute this, please enter in length 1. Let's try 10. And then notice that here now it's asking please enter in integer value, let's say 5, and it equals a 15. So this is a really good example showing how you could use default values with variables, and how, if you know that a variable is quite often going to be equal to a certain value, like for example here for message, you can use, you can shorten whenever you call the function, because you don't have to specify all of that variable, all those variables. You can leave some as defaults. Okay, I think that's plenty for this. Feel free to go look at the additional exercises, which will help you understand the concepts a little bit better if you'd like to look at those. Of course, that is optional, but it does definitely help you understand what's going on if you look at those exercises. It'll help to reinforce the concepts that we've been talking about. So thanks for watching this video, and I will see you next time.